Welcome! In the previous screencast we built a simple bar graph using D3, while intentionally limiting ourselves to using only HTML with no SVG. Hopefully this conveyed that D3 is not a SVG library, but rather a way to visualize data. But I'm sure you've been waiting to get your hands dirty with the cool stuff, meaning SVG. We're going to start off with a simple SVG primer, then move on to building a similar bar graph than the previous episode, this time with SVG and D3. Let's get started. So first we're going to take a look at SVG on its own. So in our app.js, we comment out this call to get the data from the server, because it's not required at the moment. In our main SVG element here, we code up a rectangle element using the rect tag. Now, the rect tag takes a width and height attribute, similar to what you're used to with normal HTML elements. You'll notice that the element is positioned top left, because the SVG coordinate system starts from there. I just want to show you quickly that when you don't place this rectangle inside the SVG container, it's not rendered to the page. To give you an idea, you can see when we change the width and height, the size of the rectangle changes accordingly. To move this rectangle on the horizontal axis, we use the X attribute. When we change it to, let's say, 150, it moves on by a bit. And changing it to 600, by quite a bit more. When we change it to something larger than the width of the screen, it's not visible anymore. So think of it as using absolute positioning. Similarly, when we change the Y attribute, we move this block on the vertical axis. Now we're going to take a look at circles. To create a circle, we use the circle tag. I'm copying over the rectangle's attributes. But as you can see, that didn't give us the expected result. That's because circles require different attributes. To specify the size of a circle, we specify its radius through the R attribute. And its position, we need to specify with Cx and Cy, because a circle is positioned from its center. Okay, sweet, that looks cool. What's interesting with SVG is that we use HTML attributes for positioning and size, but we can style it with CSS. For now, let's style our circle by adding a rule for all circle elements. To give it a color, we don't use background like with HTML elements. We use fill. To give it a border, we don't use the border property, but stroke instead. To specify width for the border, we use the stroke width property. What's interesting is that we can also use HTML classes to style SVG elements. So let's create a class rule in here and copy this over. And we get rid of this over here. And now, when we add this class to the rectangle, it's styled very beautifully with our CSS rule. And we can reuse this amazing styling on our circle element. So we basically get all the flexibility we're used to with standard HTML and CSS when it comes to styling the appearance of our SVG elements. Now that we've done some basic stuff with SVG, let's use it to hardcode our bar graph before we build it with D3. Let's get rid of our test circle and rectangle. SVG has a very useful group element, which we can use to group and position our elements together. Our bars in the graph will consist of rectangles and labels, so it will be useful to group them. To create a group, we use the G tag. In here we code a rectangle and give it a width of 200, with a height of 40. For the title label of the bar, we use another new SVG element, text. We position this label 10 pixels from the edge of the group and 22 pixels from the top of the group. The inner part of this tag is the text that we want to display. Now we're defining the label containing the view count for the screencast. We specify 180 for the X value, leaving us 20 pixels for the label text. We want the same vertical position as the other label, so we use 22. Again, the inner part is the text we want to display. Let's save that out, and it doesn't look great. We need to use CSS to make it a bit better. Let's get rid of all the scrap we've got in here. We're going to start from scratch for this one. Let's give our body a charcoal background. We'll target our bars by specifying that we want to style the rect items in the main element. But we could have used class rules as well. We want our bars to have a darker color. To style our text, we specify a fill color and a font rule. That looks better. Now that we've got one bar, let's duplicate it to get our graph going. We make it a bit wider than the previous one and give it different text for its labels. Now we want to move the whole bar down, the rect and the two labels. Luckily we opted to use groups, so we add a transform rule on here and move it down by 40. That looks pretty good. Let's add a third bar before we start building it with D3. We duplicate the second one, move it down a bit, and change the labels and width. Our second and third bars are the same width. That's because the third one is wider than the width of the SVG element. If we change the width at the top here to 600, you can see that the bottom bar expands. We also want our view count labels to be on the right. To do this, we do some simple maths and change the X positions for the second and third bar's labels. That looks better. Good enough for us to start building this in D3. Now that we're going to build this graph dynamically, let's remove all this hard-coded SVG. In our app.js, we get rid of the code that we did in the previous episode and uncomment the call to get the data from the tag tree website. We set the width of the SVG and the height of the bars. We have to let our bars represent the relative sizes of views for each screencast, so we need to map the data sizes to sizes that would work with our screen real estate. This is where D3 really shines. It's got a bunch of functions we can call to do this mapping for us. We get the maximum size from our data by calling D3's max function and passing in the data with a callback that returns the value we want to calculate the max on. In our case, the view count. Remember, we've set up our environment to enable ES6 in an earlier episode, so go check it out if you haven't yet. Now that we've calculated the max value in our data, we can go ahead and build a function with D3 that we can use to translate our domain values, meaning the view count values on our screencasts, to a value in pixels that we can use to plot it to our graph. Luckily, D3 makes this super easy with its scale functions. Let's call our function xScale. We use the D3 scale module and specify that we want to build a linear scale. This function expects an array that represents the min and max values of our domain. In our case, we specify 0 as the min and the max value we calculated earlier as the max. After specifying the min and max for the domain, we need to specify the min and max for the graph dimensions, in our case 0 and the width of the graph itself. To test that this scale function works, let's log out the result of passing 500 into our function. As you can see here, with the max width of the graph being 600, a domain value of 500 gets translated to 110 pixels. And 1000 to double that at 220 pixels. Let's log out the result of calling the scale function on each item in our screencast array. We loop over the screencast array with a simple for loop, and log out the result of calling the xScale function with the current screencast view count value. As you can see, this function gives us useful pixel values that we can use on our screen to represent our data. This is pretty neat. Let's get rid of that and start building our graph, shall we? This should look familiar to you. If it doesn't, go and check out our previous D3 episodes that goes deep into this part of D3. We're getting a reference to our SVG element by using its ID. We set its width to the variable which we defined earlier. Now the height is interesting. We want to make it high enough to contain all our bars, which is dynamic in value. So we calculate this by multiplying the bar height with the number of data points we want to bind to. This way we ensure that the graph is high enough to accommodate all our data. Next up, we define a join for the group items that will represent each data point. We're using a group because each bar will contain a rectangle and two labels, and we want to be able to position them together. Again, if any of this is new to you, watch the earlier D3 episodes. So, we've got a selection for the group items. Let's join that with our data and call enter to specify the rules for adding the bar groups to the screen. All we want to do at this level is specify the vertical positions for each group, which we specify with the transform attribute using a callback function to return a dynamic value based on the data. Basically, we're saying that we want the group position to be flush left and the vertical position to equal the index of the data item multiplied by the bar height, basically stacking the groups on top of each other. Now we use the group selection and append a rectangle to each group. On each rectangle, we set a width and we calculate the width in a function by using the xScale function we defined earlier. We also set a height attribute, which is the same for each bar, so we don't need a function here. The -1 we pass in here is so that we've got a bit of a gap between each bar. When we save that out, you can see that we've got nifty looking bars rendered to the screen. Very cool. Okay, let's get the labels working. To the group selection we append a text element and set its x position to the length of the bar -30. We set its y position to the bar height divided by 2. This is possible because we're using groups for each bar, so the y position is relative within the group. The text is set with a function from where we return the view count of the screencast. When we save that out, you can see that the view counts are rendered on the tips of the bars. You've probably noticed that some bars are quite small, causing their labels to be hidden. To fix this, we change the minimum value in our view range on our scale function. This just says that the minimum size of a bar will be 60. Okay, let's make it 100. How useful is this? This is a really good example of how D3 translates from data to the screen. Changing one little number affects the graph in a really elegant way. We want to show titles of our screencasts, so we duplicate this text rule here and set its x position 5 pixels from the left. And we return the title from the function, not the view count. That looks pretty cool. As you can see, the titles and view counts overlap for some of the bars, so let's change our scale again to ensure that we've got enough space for all the titles. Cool! That looks like a pretty decent graph to me. And that's the end of this episode. Hopefully I've effectively shown you how D3 helps us to translate from our data domain to our screen. See you soon!